Okay, so in this brief video, we're going to show you how to calculate a standard deviation. And to calculate a standard deviation in any data set, you have to start with the raw value. So what I'm going to do is I'm just going to enter in the x's, or the raw scores, and I'm just going to go ahead and enter in something fairly random here. This is my data set. It does not change throughout the calculations, and these data could really represent just about anything. But you'll see that these scores are not all the same, and that tells us right away that there's some variation in scores. And what we're really interested in is how much these scores vary from the mean, the measure of central tendency, how much they deviate from the measure of central tendency on average. Okay, so the first thing we've got to do then is calculate the mean. Okay, so I'm going to click here, and the easiest way to do that is by using a function call called average, and I just reference the cell range that I want to calculate the average for. So that's A2 to A10. And I hit enter. And this tells me that the mean for this data set right here is 5.33. Now, you would think that I'd be able to just copy that and paste it, but notice what happens when I do that. The value actually changes. And the reason it changes is because I've gone down one row. And Excel immediately corrects for the fact that I've gone down one row. So if you notice, what is going on here now is that it's taking the average of rows A3 to A11. So that's what we call a relative reference, is as we've moved down one cell, one row, the calculation changed in response to that. So what I have to do in the original instance and make it what's called an absolute function call, or an absolute reference, and I do that by just putting a $ in front of the row and column references. And now notice that when I paste it, it's going to be the same for every single row, which is what we want because the data set is not changing. Now, to calculate the difference between the x and the m for every single observation, I simply write equals, which means calculate this, and I'll give the reference A2 minus B2, and that gives me the difference between the score, the observation, and the mean of all the scores. I then copy that, and notice I don't need to put the absolute references because I'm expecting this to change as we move down the rows. I copy that, and now just very quickly, see how fast I ended up with the deviation score for every single observation from the mean. Now, you might say, okay, we should just stop there. But if we summed all of these deviation scores up, the sum of the deviation scores always equals 0. And that's not helpful to us because we know that different data sets will differ in terms of how much variability there is. So to know that there's variation here and then have a deviation score that always equals 0 doesn't help us out much. So we want to square these deviations to ensure that they don't always sum to 0. So the way to do that is simply by multiplying the deviation score by itself. So this becomes C2 times C2. Okay, and I use an asterisk for the multiplication. So equals C2 times C2. We're expecting that score across all the deviation scores. So I just copy and paste. And you'll notice that what happens right down here is that we get a value of 26.0. That's the sum of the squared deviation scores, or sum of squares. Okay, the notation is right here. Okay, it's sigma, and then in parentheses x minus m squared. So the sigma means sum, and then it's all of the squared deviations, and that ends up being 26.0. Now, to calculate the variance, what the variance is the average squared deviation score. Okay, and we use n minus 1 for samples because that's our degrees of freedom. And so to do this now, all we do is we take the 26, right, and we divide it by the number of scores, number of observations. Our x's, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 observations. So n minus 1 is 8. So what I can do right here is say, okay, I'm going to take D11 and divide it by 8. Okay, and that gives me 3.25. Now keep in mind we're still in the squared units, and we need to get out of squared units, and the way to do that is to take the square root. So to get the standard deviation is always calculated from the variance. We simply take the square root of the variance, and the way I can do that is SQRT, okay, square root, and then just reference the cell. So D13, I'm going to take the square root of D13, and that is 1.80. Okay, so what does that 1.80 mean? What that 1.80 means is that on average, okay, if we looked at this set of scores right here, okay, we know in this set of scores that the mean is 5.33, right? And on average, any observation will deviate around that mean by 1.80 units, okay? So one standard deviation greater than the mean would be 5.33 plus 1.80, right? So that would be what, 6 or 7.13? Is that what that would end up being? If you want to go 2 standard deviations above the mean, just take 5.33 and add 1.80 twice, and that would take you 2 standard deviations above the mean. So it's really important that you understand what the standard deviation is, what it's communicating to you, and that you can get it in Excel by using this matrix method. So the functions that we've used up to this point is the average function. Function gives us the mean. So when I wanted to calculate the average, I just entered in the array A2 to A10, and that gave me 5.33, right? When I wanted to take a square root, I used the square root function, and then I just referenced the cell that I wanted to take the square root from, and that was D13. And that gave me 1.80, okay? So just using the average and the square root functions, really saves a lot of time, okay? Now, here's what will really save you a lot of time, is if I said, okay, tell me the standard deviation for the data set, I could use the stdev function and then enter the array of the data set, so that's A2 to A10, and notice what it's going to come out to, 1.80277. In other words, that's exactly the same as what we calculated in the matrix down here, so that's a good check for us, okay? So that's how to do it in Excel, and if you have any questions, just let me know.